Here we're going to do a comparison on the conventional internal trans brake solenoid and our new internal trans brake solenoid that's powered in air. Typically in a race car and a car, you're going to have 14.2 volts, and upwards of a race car, 16 to 18 volts. So here we have them laid out on our little makeshift board here. You'll see the air lines going through. I have it utilizing a snap-on battery, which when you loop the two sides together, we actually get 16.6 volts. So I think it's a fair analysis, a little on the high side, but that should only benefit that solenoid. So what we have for our new, what we're calling the air brake, it actually doesn't use an internal valve. Typically what you would see on an internal trans brake or on an external, where you kind of utilize a modified modular valve or modulator valve, excuse me. Here is a pretty robust piston. The piston shaft itself on our air brake is 5/8 of an inch, and the piston diameter head itself is 1 inch in diameter. It is a tapered to a smooth bore seat. The inlet here is about 1/4 inch by a little over 1/2 inch overall width, and the outlet here is pretty typical, I think, what you would see, but it's actually 0.55 inches overall and about 3/4 at the larger end. So a little bit bigger here. It's actually similar. The inlet is similar here to the size overall volume of flow. So they're very similar when it comes to that aspect. So what you'll see, we have air coming in. Now, most cars these days have air, whether it's CO2 or they have onboard air compressors. This does not utilize a whole lot of air. I have it regulated just to show what our output or what we're feeding to that system, which is typically on the low end 100, on the high end 125. Our air brake can handle those, as well as temperatures upwards of 250 degrees Fahrenheit. So with that, what we're doing with our air brake here is we have a 4-port MAC valve. Now, with our kit that we're selling, there's going to be an additional arming MAC valve that's just an on-off. It seems to be the simplest way to do it. So we'll have 2 MAC valves. One is an arming, kind of like our manual valve here. These two function simultaneously. So what happens is when you go ahead and you arm, when you go to set the trans brake and you set the trans brake, it opens up that valve. When you release it, it flip-flops, sending air. So this is when you air all the time here. So when you arm it, there's air here forcing this valve closed. Now there is a spring in between the piston and the body keeping it closed, just like you would have here. Okay, there's a spring right in the back side of this, and as well as your external trans brake solenoid also has a spring. So here, same thing. So we always have a spring to keep it closed. When you go ahead and arm the system, it's defaulting air to this side, making sure it's closed. When you hold the trans brake button, it then flip-flops, forces air here. Okay, it just flip-flops, exhausts the air on this side, and then opens the valve. Now it's the same way when you release the trans brake. When you release it to go to launch, it then flip-flops again, using air and spring assist to force it closed. So we'll do a quick test here. They are both working simultaneously, so you will see, again, it's on 16 volts. Sorry if there's a little air leak on my fitting here, but if you can't see that, that's at about 122 psi. We have a little button here. Sorry for the noise. I'll put the mic up here, make it a little easier. All right, so we have a very basic operation with that. Now, for operational purposes, they're very similar. to actually, as if you were hitting the trans brake button for the first time. They're very, they're not enough to really measure, to be honest with you. However, the release side is far faster. So the side that truly counts here is much faster. And I think with just testing by slowing the feed down, and again, this is kind of preliminary data. We estimate to 0.008 of a second to 0.0125 of a second faster. Just from doing basic math, from slowing down the camera we use to record it and then bringing it over onto our computer and slowing it down again. So it's that much faster than this here. So obviously these times vary with a lot of multiple factors when it comes to the transmission. So you have to take that in consideration. Some people see 0.012 to 0.034 reaction time. Now again, that's data generally taken off the website or taken off the internet and other forums. But it also matters on the equipment using to kind of measure that, to meter that, G-force meters and whatnot. So, so the typical range of the car being able to react to a trans brake release, again, is 0.01. That could be faster, to 0.03, from what I've seen. So, I think the overall benefit right now, yes, it is a little bit faster, and I'll put a clip in the video to show that kind of quick response to that. But is that these are susceptible, the electronic solenoids are susceptible to several issues when it comes to voltage drop, as well as if you're not knowledgeable enough to wire this and you don't realize what you're doing, it could send 1,000-volt spikes back to your ECU or whatnot. So, and that's just general information from talking with people and what I found on the internet. So, but yes, that can happen. But again, there's ways to kind of wire that out or fix that with wiring. So, but here again, they are susceptible to heat. So if it's an internal, they're going to soak up the heat from whatever your trans fluid is. External, they can still get hot, and they can fail. Now, again, obviously this can fail too, but you do have issues with voltages for an electronic solenoid. That is pretty typical of that. So, you got to keep that in mind. It's just an alternative method to doing this. Again, we're still in preliminary kind of testing phases. With reaction, it does work pretty well. So we're excited, but we're moving cautiously with the way the industry is, and we just have to make sure we get enough testing and data. The next step is actually going to be installing it on the transmission and having it on a transmission dyno and doing testing from there. So we're actually going to be doing both. Possibly the three different main types, which be an internal, external electronic, and our air brake. So we're going to be doing that testing here, hopefully sooner than later. But what we're really excited about on our kit is really the overall, it's kind of our test dummy transmission here. But overall, with our transmission, let me bring the camera out. All right, so this is our new valve body. Now it's a very typical valve body reverse pattern. It's similar to the old tried and true kind of grinder design where we have the check ball that separates the circuit for the trans brake. Just as basic as it can get when it comes to a pretty standard valve body manual reverse pattern. This one you can leave in second gear. So that's one of the benefits to it, other than being just a standard valve body. Um, it uses a standard. We do have a standard valve, manual valve that we use for it as well. So we're also still doing testing on that. But what you'll notice here is our valve body is going to come with a lot of options. So we realized that we make a kit for our valve body, or excuse me, for our converter feed control, our quick spool, quick stage kit here, to control converter feed to help spool the car up if it's a turbo car. We're offering this valve body standard with the ability to mount this solenoid. You will obviously be purchasing it with our air brake. We're not offering anything different with that, but with our valve body, it comes standard. So our air brake actually mounts here. Now keep in mind, this is a prototyping valve body. So we did some testing with some holes, but this valve body will actually still work. So we're not too concerned with that, but pay no attention to that. However, so all of our designs, so this typical design, this is Rev 1. There is an additional hole here on the Rev 2 version. So this is our quick spool, quick stage solenoid. The pattern of bolting is all the same. So it's going to be the same on our, even though the block is slightly different, the manifold itself here on the body of our air brake, the pattern is still all the same. So it helps us in manufacturing. But what's really nice about this is that you can't see is that this hole is much bigger to accommodate the hole that the valve body utilizes to bolt down. So you have a 5/16 thread here and a 1/4 inch thread here. So it utilizes those two bolts here. Similar to our original design, which is still in use, our quick stage quick spool manifold here utilizes one of the valve body bolts to hold it down. So that's a nice feature, kind of add a little bit more clamping pressure to it. The thickness of our valve bodies is actually 700 thou, not a 1/2 inch. I know the standard ATI in some areas are 1/2 inch and less. The minimal thickness on our valve body overall is 700 thou. What we also are considering and doing is we have, now what's nice about this is, I'm not going to take it off, but the two ports that are here, sorry for the camera not being where it needs to be, but for the ports here that feed, that we get our feed, our line pressure and feed, they can be plugged off. So they're threaded, kind of like you have holes here. Bring it in to help it. Sorry, I'm no qualified camera expert here. Okay, so what you'll see is a pattern here. Sorry if it's terrible to make out. You'll also see a hole here. So you'll see these two ports here. That's actually for another solenoid, okay? And that solenoid mount just like that. Okay, and again, this is our original Rev. So that would mount right there. So what we're trying to do is offer kind of an all-in-one valve body as a builder type valve body. So how this works is this takes pressure feed from the manual valve, line from the manual valve to here in forward gear. And what that's utilizing it for is going to be for a lockup solenoid for your converter. How we're doing it right now is that obviously with our own custom separator plate, it's getting fed to the solenoid, coming out to here, or getting fed through the solenoid, jumping over, going back through a channel to here. And this is tapped eighth, this will be tapped eighth NPT, and you'll have a fitting coming out to run whichever way to feed, typically on a back part of the pump on the stator side. How it again, obviously would require you to have a different, not an OEM stator or pump assembly there to feed that way. So that's one of the ways. There are several other ways people do that, but this way we've opted to do that. So, but again, as a builder series and kind of our idea of doing it, and of course that can change. This is just all preliminary. It really depends on the market and the reasonable products out there. But again, that option is there, and that can be plugged off, and actually will come plugged off if those features, even if they're ordered or not. Um, but the options are there. So the solenoid on Rev 2, uh, the actual solenoid is different. Sorry, the solenoid is different because it becomes a kind of a 3-port solenoid instead of a 2-port, and then there'll be a hole here. Now, all of our solenoids are going to be that way. Excuse me, our manifolds are going to come that way now, um, for the ease of manufacturing. Hopefully, that's easier. So for the ease of manufacturing, the only modification, the manifold itself, doesn't change at all. Besides, we're putting a hole here. So that was the beauty of having just a slightly different cartridge, same coil, Hydroforce cartridge and coil. The beauty of that is all we're doing now, which we have implemented, is a threaded MPT port here. And the reason we have the threaded MPT port there is specifically for the converter, lockup converter, so that it dumps off that fluid, and disengaging that. So it's just something, again, very, very typical. And I'll put some pictures in here. I'm not going to take that off right now, but I'll put some pictures in here of the actual, the reverse side of the valve body. Kind of see what it looks like. And it's, again, very basic. Um, but I think for as a builder series, user series, we're going to offer these features here, but again, they're going to be kind of with the ability to plug them off. So none of our holes, they're all blind holes that bolted down that we add. Obviously, besides these 3 bolts, one for the trans brake solenoid and one for the converter feed solenoid here. They go all the way through, obviously, bolted down to the case. Again, very standard, very simple. So that's kind of a quick look at our new air brake and how it compares to that. Nothing to get too excited about with performance, but I think it is that little bit faster. It actually takes something like this a little bit longer to close. Now, an external trans brake, right, and typically in your 400 here, that utilizes the modulator circuit. Some valve bodies, what they're doing is also forcing fluid back to help it close, which is beneficial. But that does work. However, the best method, and I honestly would argue 2 things. One, the tree killer as an internal from Extreme Automatics is one of the best in my opinion. But externals can also be really beneficial. However, they're only beneficial or the best overall, in my opinion, is if you're boring that circuit out to allow more surface area on a custom valve to be able to close that valve much faster. It's utilizing line pressure to come back and close that valve. So I know Rossler does that. I'm sure M&M does that, and other builders do that. But that's the only way to really get that to do what you need it to do, is having that. There is no the solenoid is only assisted by a spring to close it, and some pressure a little bit different on that. But here, like on Lonnie's on Extreme Automatics, the solenoid pulls it to open, doesn't push it to open like this one here. Kind of similar to mine, where air pressure pulls it down, opens it up. So unless you have a massive air leak, which on a turbo car, that's going to be a bigger problem for you. But typically, a CO2 system would be able to operate that, no issues whatsoever. These manifolds, these MAC valves are actually, for several reasons, are actually mounted on the near by the governor cover. The hoses are fed through. We're still working on that kit. We're going to be coming up with kind of a one size fits all cover for also for external dump valves for that. That's going to be pretty typical standard stuff, whatever's out there market wise, whatever you'd like to purchase. We're not going to try to monopolize too much of our own stuff for that. We don't want to do that, but to leave options open for that. However, just to make it easier to be able to connect in your air hoses. So with the solenoids out here, it's a shorter run of air hoses, which we're also ensuring that the fittings and hoses can handle the temperature as well. So we're still doing some testing on that. So there's a lot of things in the works when it comes to that. But hopefully, it's something different with the market, and hopefully it works out. And again, offering it with our valve body. So, but yeah, so the MAC valves, again, CO2 or onboard air, compressed air, will work. There's also a couple of things we're playing with. We're hoping to get a lot of feedback. We already have got quite a few feedback with some of our guys who run LDR and some pro mod stuff too. And a lot of, some street / semi-competitive stuff. No time guys that we have a lot of feedback on that. They're more of the positive feedback. I really haven't had anything negative about it quite yet. But we got to test it. So that's going to be one of the next steps to do. So it's different. That's kind of the person I am. My personality is kind of doing something a little bit different. And I'm excited to see what it actually does in a transmission. If it's a huge turd, then I'm going to make a video saying it's a huge turd. But I'm not going to make a video of it being this enormous success, even if it is one. I just want people to utilize it, or if it does work, utilize it and have better success of, their trans brake not working due to voltage issues. Especially when you're running just a battery, you're not running an alternator, so less things to draw down on and less voltage spikes from the solenoid. Hopefully that's a benefit to that alone, not necessarily being. And again, from what I found with testing, and I actually max it out to 20 volts. Kind of stupid, but I think I accidentally did that. But it was fast, but this was still faster closing. So again, 2 MAC valves, the whole kit is coming. I kind of have a pre-order thing on the website, but I don't think that price is really finalized yet. So there are some stipulations that I'm going to adjust on there too. But we still have to do testing. So hopefully we'll be doing testing here in October and get that finalized. Actually going to put this transmission together too. But yeah, and again, I'll put some photo montage in here of all this stuff here, what it looks like individual. So any feedback is good, good, bad, or indifferent, whatever the case may be. Let me know.